This video is on solving equations with roots. So this method works whenever you have just one term with an x in it in an equation. So for example, if you look at all four of these examples on the page, there is only one term that has a variable x in it. So in example 1, we have an x squared and a 100, an x squared and a 17 in example 2. So this is the only time we can use this method, but it works really nicely. And you'll see we'll be able to work through these problems very quickly. So the idea is that in example 1 we have x squared is equal to 100. So if I want to undo the squared exponent, I can square root both sides of the equation. Then on the left hand side, the square root and the squared would cancel one another out, so I'd be left with just an x. And on the right hand side, I would have the square root of 100, which is 10, or don't forget there's a second solution, which is negative 10, because negative 10 squared is also 100. In example 2, it's the same idea. I can square root both sides of the equation. The squared cancels out with the square root, so I have x squared, just x is equal to, now the square root of 17 is not a perfect square, so I can write my solution as just plus or minus the square root of 17. In example 3, I have x to the third minus 8 is equal to 0. Now, one thought is you could factor this as the difference of two cubes, but if you didn't want to do that, you could also solve this using roots. And the idea would be you want to move the 8 over to the other side, so you could add 8 to both sides. You want to get the x cubed by itself. So then I have x cubed is equal to 8. If I cubed root both sides now, a cubed root would cancel out the cube, and I have x is equal to, the cubed root of 8 is 2. And I get my solution. Now in example 4, you could start by square rooting, but it's actually a little bit better to get rid of the 2 out front of the x squared and get the x squared by itself before you square root. So if I divide by 2, it's going to cancel the 2 out on the left, and I get x squared is equal to 25. Now when I square root, I get x is equal to 5 or negative 5. Now this next example looks a little bit different. We have the quantity x plus 3 squared is equal to 100, but it works exactly the same way as these last couple examples because we have something being squared here. The thing that's being squared is this entire x plus 3, but whenever we have something being squared, we can always square root to undo it. So I can square root here and square root on the right hand side as well, and the square root will cancel with the squared, just like it did in the previous examples. I don't need my parentheses anymore because I got rid of my exponent, so now I just have x plus 3 is equal to 100. But I can't forget there's another situation too. There's an or. I also could have x plus 3 is equal to negative 10. So now I have two separate equations I need to solve. So if I do x plus 3 is equal to 10, I can subtract 3 here and get x is equal to 7. And in my second equation, when I subtract 3, I get x is equal to negative 13. So those are two possible solutions to x plus 3 squared is equal to 100. Okay, so let's look at one more example here. We have 4 times p plus 2 squared minus 20 is equal to 0. So the idea here is we just want to kind of peel away the 4 and the negative 20 so that we get the p plus 2 squared by itself on the left-hand side. And then once we do that, we can square root both sides. So to get rid of the minus 20, I can add 20 to both sides, which would give me 4 times p plus 2 squared is equal to 20. Now to get rid of the 4, I could divide by 4 and have p plus 2 squared is equal to 5. Now I'm ready to square root. and I get p plus 2 is equal to, well, 5 isn't a perfect square, so I can write plus or minus the square root of 5. And now, to get p by itself, the last thing I would do would be to subtract 2. And this gives me p is equal to, well, I can't really combine the square root and a number unless I have a calculator. I could plug that into my calculator. But I'm actually going to leave my answer as negative 2 plus or minus the square root of 5. Alright, so here are 3 problems for you guys to try on your own, and we will be discussing the solutions to these problems, and I can answer any questions tomorrow in class.